So today our speakers are Teresa McGrath, who is the Chief Research Officer at Healthy Buildings Network. And we also have Kimberly Siegel, who is the Research Knowledge Manager at Perkins and Will. And they're going to talk to you today about material health and embodied carbon and how we line those two drivers up. So I'll hand it over to them. Thanks very much.
Well, welcome and thank you, Carolyn. We're really excited to be here. Today, Teresa and I are going to do an encore performance of a presentation that we gave, or a panel that we were part of at Living Futures last year, called Material Health and Embodied Carbon at Odds or Aligned. So really looking at that intersection. I'm Kimberly Siegel, Research Knowledge Manager at Perkins and Will. I also co-direct the Material Performance Lab. I'm joined by Teresa McGrath, who is the Chief Research Officer at Healthy Building Network. When we initially presented this presentation, we were also joined by two others. So Mary Dickinson, who's my co-director of the Material Performance Lab, who specializes in material health, as well as Stacy Smedley, who is the Executive Director of Building Transparency, which I'm sure many of you are familiar with, is the brains behind the EC3 tool. Continue. This is our agenda for today. Why material health? We'll dive into a little bit of that, and then we'll talk about why embodied carbon. We'll talk about the intersection of the two. And then we're going to highlight some of the findings from our research. We looked at two different case studies, one related to flooring, so specifically looking at resilient flooring and carpet, and then also looking at gypsum drywall. So we'll share some of our findings, and then we'll close with some potential interventions and actions that you can take to kind of empower some of your decision making. Whoops, it's a fast mouse over here. So really quickly, for those of you not familiar with Perkins and Will, we are a global design firm with a pretty robust research ecosystem. We have research-informed practice for practice-informed research, and we tend to focus on a variety of labs or areas of inquiry. So you'll see here, we look at things like human experience, energy, building technology, and as I mentioned, material performance. And specifically out of material performance, our goal is to advance the practice of design through research, but also link back to some of AIA's materials pledge components. And so I'll pass it on to you, Teresa.
Yes, hello, I'm very happy to be here. Thank you for the invite and the opportunity. A little bit about Healthy Building Network. As was mentioned in the intro, I lead the research team here at Healthy Building Network. We are a national nonprofit. I'm personally based in St. Paul, Minnesota, and our mission is to advance human and environmental health by improving chemical transparency and inspiring product innovation. So we work to do that through research. We do a lot of education and policy advocacy. Essentially, we try to build like tools and resources to translate a lot of complex information about human and environmental health hazards of chemicals and building materials into simple guidance. And the ultimate goal of that effort is to change the way products are made so that products are inherently safer for all people. I'm going to start the conversation with why materials matter from a building product perspective. So building products, you can go to the next slide, are the focus of our work due to the sheer volume of material that they represent in our day-to-day interactions with them. The EPA estimates that people spend over 90% of our time indoors, and that indoor air often contains pollutants at 2 to 5 times higher than outdoor air. So we're intimately exposed to the chemicals that migrate from our built environment. And there's impacts throughout a product's life cycle. You'll hear this, this reoccurring theme throughout the entire presentation. The materials that we put in our homes, in our schools, in our buildings, they of course matter for the health of families, students, and workers in those buildings, but they also matter for those making those building products, or those installing those products, or the people living around the facilities that make or dispose of those products. In fact, if we go to the next slide, a study showed that babies in the US are born with over 200 industrial chemical pollutants in their blood. And these same chemicals can affect brain development, the way hormones work in the body, and are associated with the development of cancer. Next slide. This picture is from a recent incident that many of you may have heard of, about the vinyl chloride train crash in Ohio. And this is just an example of those impacts that happen outside of the building before the products or while the products are being made. Those cars were full of vinyl chloride, which is a chemical used to make vinyl flooring and PVC pipes. The building industry is by far the biggest user of PVC, and the use of hazardous materials is driven by the demand for these products in new construction and renovation. Vinyl chloride is a carcinogen, highly flammable, even causes blisters when you're in contact with it on the skin. And authorities in this case, when this train crash happened in a residential neighborhood in a small town in Ohio, they decided to burn it. The best option was to burn it, which released other hazardous chemicals into the air. So imagine for a moment if these train cars, instead of being filled with vinyl chloride, were filled with wood flooring or copper pipes or ceramic tiles. The impact on the community would be much, much different. And the next slide. So this talk is about the intersection of carbon and health. As climate changes, we can start to see some of the direct connections between climate and toxic chemicals. We see how some buildings materials directly contribute to global warming by simply having a high global warming potential associated with the chemicals in their manufacturing. We also see how toxic chemicals increase communities' vulnerability to climate change impacts. So, for example, as chemical plants that are at higher risk of destruction, that will lead to chemical releases in those fence-line communities. We also see that as we work collectively to reduce our energy consumption, we're making buildings more energy efficient, which is great, but we also need to consider that these tighter buildings trap more chemicals inside, making our material choices that much more important. The good news is that change is possible and change is happening. So we are seeing through efforts like EC3, through efforts like the Living Building Challenge and Living Product Challenge, that innovation is possible and it's happening. The market demand is really driving this innovation. So I, thank you to everyone here who's part of that story. And a couple examples I'd like to share of problems that are solved or almost solved are, for example, large retailers have banned a developmental toxicant called orthophthalates in flooring products. That's really great news. So we are largely out of orthophthalates in flooring. It's being used elsewhere, but let's celebrate those wins. We're also seeing movement out of PFAS, which is a perfluorinated alkyl substance. It's sometimes known as a forever chemical because it's very persistent in the environment, and carpet manufacturers are phasing out of the use of PFAS and towards different stain treatment opportunities. So we're seeing some change happen, and we expect that to continue. Now you'll hear me say throughout the conversation, I'm going to be talking about material health. So when I say material health, I'm talking about the hazardous chemicals present in or used to make, install products, or hazardous materials used at any point in the production of that product. And then next slide, when I talk about safer materials, I'm talking about materials that avoid the use of hazardous chemicals. And the way that we understand that is our team, the research team that I work with, we dig deep into what products are made of how they're made, and to understand those material health concerns. And then we identify key opportunities to reduce the use of those hazardous chemicals for the product category. And we translate this into an easy to use guidance for product selection. This is called our hazard guidance. So we use this to encourage project teams to move away from product types in the red. Those are product types with high hazardous chemicals use, and prefer those product types in the green and yellow, which are best in class, so best in that category from a material health perspective. And then I'm going to hand it to Kimberly to talk about why materials matter from an embodied carbon perspective.
Right. Thank you, Teresa. So, it feels a bit, we understand that this audience is very knowledgeable, and I would say the baseline understanding of embodied carbon within our kind of industry is a pretty good starting point with this audience. But nonetheless, we are going to just set the playing field so it's level and make sure that we're covering all of our bases here. A lot of sports analogies in that. So why carbon matters? So carbon emissions are obviously becoming an increasingly urgent and, I would say, discussed issue. I'm sure in British Columbia this past winter, you've experienced a whole host of unique weather events, to say the least. And these impacts of climate change that we're experiencing as a society, coupled with some of the latest science out of the Intergovernmental Panel on Climate Change, is kind of showing us that the global temperatures that we initially thought were going to be increasing are actually increasing at a rate even faster than initially projected or modeled. And as many of you know, these impacts are not felt uniformly, and they're not uniformly distributed across the Earth. They're seen more exacerbated in certain areas. So the Arctic is certainly seeing, I would say, a broader swath of impacts and a more intensified swath of impacts than, say, somewhere in the equator. But nonetheless, impacts are being felt and ripples are being felt everywhere. And if only climate change could exist in its own isolated silo and bubble, but it doesn't. It is the kind of thing that is inextricably linked to a whole host of other impacts and issues, from biodiversity to ecosystem health to human health. And this particular talk that Teresa and I are giving today is specifically focused on that intersection of climate change and human health. So this diagram right here, you may have seen it before. It's initially from the Center for Disease Control. It's been republished and reposted on several other publications, so you may be familiar with it, but it does emphasize this connection and this link between climate change and impacts like heat-related illness and malnutrition and asthma and other respiratory issues. There's just this kind of positive feedback loop where if one thing is triggered, it just continues to grow in its intensity. And so my guess is that the majority of attendees on this call work within the built environment. You're probably within the architecture or construction or engineering kind of sphere, or perhaps you're in real estate. But nonetheless, my guess is that you work somewhere in the built environment. And according to the global carbon dioxide emissions pie, the built environment makes up about 40% of overall emissions, with 11% of that 40 actually being attributed to building materials, or the embodied carbon component, which we'll talk about next. So what do we mean by embodied carbon? For the purposes of this presentation and for our research, which we'll be discussing, we define embodied carbon as encompassing the greenhouse gas emissions arising from the extraction, manufacturing, transportation, installation, maintenance, and disposal of building materials, or materials in general. Obviously, embodied carbon can always be juxtaposed with operational carbon, which is referring to the operations of a building. So the lighting, the HVAC systems, the heating, cooling, everything that goes into the operations of a building. And so as our buildings are becoming increasingly more efficient, which is something that Teresa already touched on, and our grid is getting decarbonized, and there's a whole push toward, urban scale kind of renewable sources, all the things that we are really excited about and looking forward to in terms of making our buildings more efficient. We can't ignore that while the operational piece is decreasing, this embodied carbon component becomes that much more significant, and we become more aware of the impact that we have with the materials that we're selecting to build the buildings that we're designing and the environments that we're designing. And fortunately, environmental product declarations are really proliferating right now. I would say even as recently as 5 years ago, we didn't have the amount of information and access to information that we have that we do now. So environmental product declarations are, if you're not familiar, are similar to like a nutrition label on your food. It just kind of showcases what your life cycle impacts are and global warming potential of the material product that you're looking at. And they can come in the form of type 3 EPDs where they're third-party verified and they're specifically looking at an individual product, or they can be an industry-wide environmental product declaration. But nonetheless, these bits of information are really helpful in terms of us assessing kind of where we're at with the materials that we're building with. And it's worth noting this slide and the next one are slides that Stacy presented. And I think the point of what she was trying to emphasize in this particular talk is that EC3 and building transparency kind of took the same approach that Teresa just outlined from a health product declaration perspective, from a healthy materials perspective, where you're researching the materials and you're identifying the key opportunities to reduce within a product category. And then you're developing guidance to point out product types with typically lower embodied carbon. So it's mirroring what Teresa just explained from like trying to specify and clarify material health and make sure that the materials that we're specifying are not as toxic as other options. And so I want to end with this last slide just to talk about our research. So Healthy Building Network and Perkins & Will partnered up to embark on this study to look at this intersection a little bit more closely. And when we selected our case studies of flooring, so resilient flooring and carpet, as well as the gypsum drywall, we limited our study from the embodied carbon perspective for just A1 through A3 within the life cycle of a product. So specifically looking at that raw material supply extraction, that transportation to the manufacturing site, and the manufacturing itself, also known as cradle to gate. And the reason why we limited our data points to that is because a lot of the information that we culled and kind of investigated and researched was on through EPDs through the EC3 portal. And at the time, EC3 was only showing us A1 through A3 data. They have now updated and they're including, should you choose to show A4 and A5 data. But at the time, only A1 through A3 was available and we published last year. So that explains the kind of the bounds of our research and our data that we were working with.
Great.
So pass it over to you, Teresa. Yeah.
Yeah, thanks. So what we were looking at is this intersection of material health and embodied carbon. And what we were seeing out in the marketplace was that they were being talked about as these separate goals, these separate tracks. Now, if you attend Greenbuild, there's material health over here, there's embodied carbon over here. And it seemed like project teams were kind of feeling torn between either focusing on finding products with safer chemistry or focusing on products with low embodied carbon. And if you go to the next slide, our hypothesis was that there is overlap. There are product types that are both optimized from an embodied carbon perspective and optimized from a material health perspective. So for this project, our goals were to define the product category drivers for embodied carbon, define the product category drivers for material health, and identify where those align and where they are conflicting. And then using that information, develop guidance to help project teams choose safer low carbon products. And we did all of this by reviewing product literature. We used publicly available tools like the EC3, and we went and did a number of interviews with industry experts, including manufacturers, to better understand their perspective and as the product experts, what they were doing and what they saw as drivers for each of those categories. So now we get to dive into the fun stuff, into the results. So we're going to start with flooring. We did end up having to limit the scope of our project research to just looking at resilient flooring and carpeting. So resilient, we focused on PVC or vinyl flooring, and then carpet. What I'm going to start with is the material health drivers. So from a material health perspective, we know that the most effective way to choose a safer flooring is to choose product types within the category of flooring that typically use safer materials. Now that sounds like kind of a duh moment, but what we are seeing in practice is that sometimes people get distracted by looking at diving into specific manufacturer products. And what we're encouraging people to do is take a step back and say, okay, my challenge is to find a flooring. And so let me think first about what product type within flooring is going to be the best to meet my sustainability goals. And when I say product type, I mean carpet is a product type within the category of flooring. Linoleum is a product type. Vinyl flooring is a product type. So, the guidance here is to choose a specific, the best way to avoid hazards is to avoid those product types in the red zone and prefer product types that are in yellow or green in our guidance. And this is again HBN guidance that you see here on the screen. So examples of preferred flooring product types include linoleum, solid wood, ceramic tiles, or PVC resilient flooring. Now, once you've narrowed in on a preferred product type, then you can choose the best manufacturer product, the best specific manufacturer product within that type. Now, within these product types, you can still improve. So the example here is, no, you were right on the carpet. Perfect. It's been a while since we did the original presentation.
The remix of it, yeah.
Yes. So when we dive in on carpet, so carpet was sort of lower on the hazard spectrum or on our guidance, but there are opportunities to improve from a material health perspective within the carpet category, within the carpet product type rather. So we found the biggest material health drivers were the three here listed. So toxic heavy metals and fly ash. This is often a filler used in the backing of a carpet. The manufacturing releases from vinyl and polyurethane production. They are they use a lot of hazardous chemicals in the manufacturing process of vinyl and polyurethane. And those are the most common backing materials in carpet. And then PFAS, or per and polyfluorinated alkyl substances. These are those forever chemicals I mentioned earlier. Carpet industry is doing a great job of phasing out of PFAS, but we're still calling those, a potential driver for material health because they're not entirely eliminated yet. So of course, the biggest opportunities to improve material health within the carpet product type are choosing products that avoid these materials. On to the next, resilient. So the resilient flooring was the next product type that we looked into in detail. We focused on vinyl flooring for the most part for resilient flooring research. And what we found was that the manufacturing, and the reason we focused on resilient flooring or vinyl resilient flooring was that the majority of the marketplace for resilient flooring is vinyl at the moment. The biggest drivers from a material health perspective include the manufacturing releases from vinyl production. So they use mercury, asbestos, and PFAS to make PVC, to make the chlorine and the vinyl chloride monomer that goes into PVC. So the whole production process is fairly chemical intensive. And then we also see some issues with legacy chemicals of concern and recycled materials. Old PVC or PVC coming in from other sources like cable and wiring can have chemicals of concern, whether that's orthophthalates, in old flooring or heavy metals from wire and cable that can introduce legacy chemicals of concern, these older chemicals of concern, into new materials. So chemicals that have been phased out could be reintroduced by using recycled materials. So we just encourage, in order to improve on the resilient flooring side, is to look for non-vinyl resilient flooring options and to very carefully screen any recycled materials that are used. From in similar ways to material health, the biggest opportunity to reduce embodied carbon is to avoid the product types with the highest embodied carbon and choose product types with typically lower impacts. So carpet, for example, tends to be the worst choice from an embodied carbon perspective, due in large part to the short service life of carpet. So carpet typically has a service life of 5 to 11 years. That was what was used as an assumption in this the report that generated this graph here. Though we've heard from our partners that have indicated commercial carpets are discarded every 3 years. So it could be even larger impacts. And what this means is the service life is so important because the impacts used to make that product are generated over and over again each time a replacement product is made. Go to the next slide. Now again, within the carpet category, there are ways to improve embodied carbon. So we looked into that. We identified that any efforts to reduce embodied carbon for carpet should really focus on that carpet fiber, which is the nylon, typically nylon, because the manufacturing of nylon is where 70% of the embodied carbon impacts lie. So one way to do that is to incorporate less virgin nylon. So using recycled nylon in carpet can be a great way to reduce the overall embodied carbon impact. So if we look at resilient flooring, it's a similar story. So resilient flooring, there are ways to improve even within that category, within the product type of resilient flooring. I will say that resilient flooring had a lot less information available from embodied carbon perspective than when compared to carpet. And part of the reason is that there's a lot more variability in resilient flooring marketplace in terms of materials, in terms of composition, weight per square foot, lifespan. So it was just a bit more a variable story that we were uncovering. But we did see that one thing that we could pull out from that work was that the best way to improve embodied carbon and resilient flooring is to focus on the resin production and to focus on service life. Again, if the product is there and can last for more than 15, 20 years, then that will reduce its overall impact on, as you won't have to replace the material. Now, when we take a step back and look at all this data together, we start to see that the points of alignment for material health and carbon are plentiful, and they outweigh the points of conflict. For example, by choosing a product with a long service life, by choosing a bio-based product like wood, linoleum, or cork, by avoiding or minimizing the use of carpet, which has a inherently shorter service life, by using circular and safe materials, we can optimize material health and embodied carbon in the flooring product category. Now, there are points of conflict, and I'm going to go to the next slide to show you an example, the example of PVC. So you can see PVC over on the right-hand side is sort of middle of the road from an embodied carbon perspective. It's sort of right below all the bio-based materials, But when you look over at the embodied or the material health perspective on the left-hand side, you can see that it is one of the worst in class from a material health perspective. So you can start to see that while there is a lot of alignment, there is still some points of conflict, and that's why it's still really critical to consider both when you're making material decisions. While we do plan to continue this research, and I think Kimberly is going to talk a little bit about our next goals, we do expect to see continued alignment like this. So project teams don't have to choose between meeting their carbon goals and meeting their material health goals, and they can do both. Now I'm going to switch gears and talk about our results in the gypsum drywall, and I'll spend a little less time on this than I did on flooring. But the great news is that we still saw a lot of alignment. From a material health perspective, the biggest drivers for gypsum drywall include mercury releases from manufacturing sites and toxic additives. So when we talk about mercury releases, I'm talking about the use of FGD gypsum or synthetic gypsum. Also, it can be described as gypsum from coal-fired power plants. It's a waste material from coal-fired power plants. And this can contain hazardous heavy metals such as mercury. Mercury, of course, is toxic and persistent, and it can be released from the FGD gypsum during the drywall manufacturing process, either during the dehydrating or calcining process or just the board drying process. And according to data reported to the EPA by drywall manufacturers, mercury emissions from those facilities increase as more FGD gypsum is used. So to avoid these emissions, you can choose drywall with natural gypsum. And then the second driver is toxic additives. So additives like antimicrobials and dispersants and flow aids can be hazardous to humans or the environment. And one of the most common additives are antimicrobials added to mold-resistant drywall. So to avoid those, we only use mold-resistant drywall in locations where it's absolutely necessary. If we hop into the embodied carbon drivers, we saw in our research that the biggest embodied carbon impacts occur during manufacturing. So this is a little different. This is interesting and different than the flooring story. So all those in the flooring products, all the biggest impacts were happening during the raw material production stage. But in gypsum, it's different. And this is because the calcining and board drying process is very energy intensive. Therefore, the biggest opportunities to improve the embodied carbon for drywall is to either use renewable energy at those facilities or to make the process more efficient. And so when we hop down to see the alignments, the great news is that, again, embodied carbon and material health drivers mostly align. So using renewable energy and the use of natural gypsum are very aligned, because if we think about coal as the producer of FGD gypsum, or the need for the starting material for FGD gypsum, that's not aligned typically with reducing our overall energy or fossil fuel use. And in many parts of the world, the use of coal for power is already decreasing as the use of renewables like solar, wind, or biomass are increasing. And as the use of this coal-fired power plants goes down, or as they shut down altogether, the drywall industry is already naturally moving away from mercury-containing FGD gypsum and towards natural gypsum. Another opportunity to align our lighter boards. So thinner or lighter boards use less energy to produce. From an embodied carbon perspective, that's a win. Lighter boards also use less materials generally, which will translate to less additives overall, including less additives of concern. Now, of course, dematerialization is limited by fire rating and acoustical performances, but the lighter and less additives is going to translate to a win from a material health perspective as well. Now, there's of course just this a point of conflict, just as we saw in the flooring area. One of the things we heard is that there can be additives that can be added during the drying process to enable the use of less water and therefore decrease the energy needs during manufacturing. And some of these additives can have hazards associated with them. So while we're decreasing, the additives can help from an embodied carbon perspective, they may be a challenge or a conflict from a material health perspective. So again, important to consider both. And I'll hand it off to Kimberly to finish off the presentation.
Yeah, I'll take us home. All right. Well, thank you, Teresa. Really great overview again. So you're probably wondering what can you do? You know, now that you have this information, and like I said, I'll put a link in the chat of the publication that we published last year of this white paper and these findings. But in the interim, we're going to give you the cheat sheet here of kind of some potential interventions on a grander scale and then some actionable guidance. So the first thing that we probably want to highlight is this idea of regulations on chemical content. Teresa mentioned this in some of her overview about why material health when she talked about the orthophthalates. I think that's what you were talking about, yeah, and the PFAS. But this idea of creating legislation that's looking at classes of chemicals rather than just individual chemicals will help kind of facilitate omitting them from the supply chain overall. So a good example of that is actually a recent bit of legislation from the US Environmental Protection Agency. That's a ban on polychlorinated biphenyls or PCBs. And it's targeting this particular class of chemicals, removing it entirely from the supply chain. Teresa had mentioned in her example that it was eliminated from flooring, but not PCBs, but is it orthophthalates? Yeah. They were eliminated from flooring, but that doesn't mean it doesn't exist in other areas of industry. And so without targeting the class of chemical itself and just an industry, it doesn't really help remove it entirely. So kind of thinking more holistically about policy decisions. Another bit of an intervention that can happen is just overall materials disclosure, either incentivizing it or requiring it. So a good example is at Perkins and Will. For any vendor to come in and present in our, in our studio or to our libraries, they need to come in with products that have HPDs, health product declarations, and EPDs. Otherwise, we're not interested in even considering them because we need to be able to evaluate the data that's coming with those particular products. And so that's something that we as a firm do. We encourage other firms to do this. We think that kind of moving the needle toward disclosure is what's going to get us to a place in our industry where we understand more, we can actually make more informed decisions that move toward safer and lower embodied carbon content. Another bit of kind of interventions are these end-of-life policies. So these are something that we kind of highlight more from the producer side or the vendor side. So this would fall on extended producer responsibility, just kind of thinking holistically. This is more in line with like circular thinking and circular economy, but nonetheless, it's an attempt to kind of limit the landfilling and burning that we're seeing. One of the most, I think, eye-opening data points that Teresa and I came across in our research, in our interviews, in talking to a lot of carpet manufacturers and resilient flooring manufacturers, we uncovered that even all these companies that have really robust take-back programs, of the take-back programs of the content that they get, 95% of what they get is actually only used to actually be incinerated at landfills for waste energy. And so if the whole point of taking back a material is to then just incinerate it and use it for waste energy, I mean, that's one purpose, that's great. But at the end of the day, the material itself isn't being upcycled to a product of this equal or even better value. And we would love to see that at some point. There's quite a bit of room for growth, I think, in that area. And then one kind of last potential intervention, obviously we are presenting to CLF Vancouver. British Columbia is pretty forward thinking. You have pretty progressive building policies, more so than a lot of places in the US, I would say. And one of the things that seems to be a focus area ripe for, I think, some attention is this idea of waste collection and management and just financing it, finding a finance mechanism to really optimize the waste products that we're creating, because there's opportunity within that we haven't tapped into. So perhaps British Columbia can lead the way in that potential opportunity. So actionable guidance, what can you as an individual do? Product types first. So Teresa mentioned this in kind of both components of the presentation, right? Not just in flooring, but also in gypsum drywall. You're not just looking at a product category, you're considering product types within that category. And sometimes you'll have healthier and lower embodied carbon product options within that category, but your performance, determinants or what you're designing require you to use something that is maybe falling lower on that list. So once you've selected your product type, the advice is to find typically safer product types and lower embodied carbon product types. You can do that through a whole host of different data sources out there. We've already mentioned EC3, there's healthybuildings.net, there's Material Palette. We'll drop all these links in the chats that you have them. But there's guidance out there to help you. It's also kind of worth noting, we've really promoted the idea of HPDs and EPDs on this talk. And another fascinating data point that we came across, or was maybe it was just eye-opening for me, but I think it was eye-opening for all of us. One of the interviews that we conducted kind of pointed out something, which is third-party verified EPDs. The third-party verifier is not verifying the actual data points that you're seeing. It's not verifying whether or not the product itself is actually emitting that amount of global warming potential. It is merely verifying that the vendors actually followed the product category rule for that particular product correctly to report in the EPD. And I think that nuance is worth kind of highlighting, because while we continue to grow our databases of knowledge and we have access points for HPDs and EPDs, there's going to be a margin of error. And it's worth noting, but that margin of error is still better than nothing, and it's something to go off of. So it's just kind of make you aware of these kind of data points as you're going through that and making some decisions. One last bit of actionable guidance is, once you have your product category or product type down, you can actually sort by manufacturers, and using that information from HPDs or EPDs, you can kind of go through. Manufacturers are really responding right now to this demand from the design side, where we want to know more, we're hungry for information, and they're responding in kind with these third-party verified documents. So it's up to us to kind of go through and cull through the different manufacturer documents and compare them to either the CLF baseline, or from a health perspective, comparing it to the health product declaration or healthy building network guidance that Teresa had shown. She showed two different types of guidance today for flooring and for gypsum drywall. But if you go to Healthy Building Network, you can actually find all of their home free classifications of different material product types. And I think Teresa can maybe drop a link in the chat, or I can. And so next steps, you're maybe asking, okay, like what else can we do? Continue to ask, continue to demand information. The more I think we as just an industry, as individuals, continue to team up and be inquisitive and to ask for more information, the more likely we are to get the information we're seeking. So it's really kind of just a good reminder of that. And we're continuing this research. The next product category that we're looking at is actually insulation, and we're looking at a variety of different product types right now. So we're just continuing this now that we have our methodology down. Our goal is to continue producing white papers that explore this intersection of other case studies. And that is all we have for you today, but we have about 10 minutes for Q&A, so I'll stop sharing.
Thanks so much. I thought that was really great, really great. We had a couple of questions in the chat, which I saw Teresa had already kind of touched on some answers. Do the original askers of those questions want to carry on? Any more thoughts there? I'll just open the floor to them first before opening up to everyone.
Oh, hi,
Penny, yeah.
Oh, okay. Hi, everyone. Yeah, I was just asking about the natural gypsum and if it's, how is that sourced? How is it dug up? Is that a environmental problem if we specify that, although we would be escaping some other problems?
I'll let you take
Yeah,
that.
that's
Teresa.
a really great question. And certainly like mining impacts are absolutely considered when we generate our product guidance. And so when we think about it, it's all kind of relative. It's relative to one another. So while the mining impacts are there, we're comparing it to the impacts of the production of FGD gypsum, which is from coal. So the coal would be mined and then as well burned, and then the waste product would be used with the release of mercury. So when we're comparing those, we're considering the impacts, the life cycle impacts of both of the processes. So absolutely, mining will have impacts of its own, but in this particular case, the mining of natural gypsum, from our understanding, is a relatively abundant resource. We asked if there was any fear of this being a resource that would run out anytime soon, and there wasn't. From the manufacturers that we interviewed, didn't indicate that that would be the case. So when we compared those relative impacts, the natural gypsum did still sort of win in terms of material health overall impacts. And that's not always the case, I would say, is that there's some natural materials or some mined metals, for example, that probably wouldn't be better, or when compared to like, a wood flooring to, I'm trying to think of a good example, but I'm not coming up with, copper piping. Is an example where there are significant mining impacts to copper. They still outperform PVC or vinyl when you're comparing them from a water pipe perspective, but were much closer in terms of impacts to each other in that case.
Thank you.
Yeah, great question.
I see Ahmad's question as well. Or was that, no, you answered the one above that, right? No, I'm seeing.
I don't think his question or Ahmad's question was answered.
Yeah, no.
You still in the room, or I could read this out. Does the recycled content of gypsum board correlate significantly with embodied carbon and material health? So asking specifically about the recycled content.
Yeah, that's a great question. So sometimes FGD can be considered, FGD gypsum can be considered post-industrial recycled content or pre-consumer recycled content. So you do have to be careful about the term recycled. I'm going to assume your question was referring to post-consumer recycled content, so old drywall or old gypsum products being recycled into new gypsum products. And I would say that from a material health perspective, that is preferred. You don't have the mining impacts of natural gypsum, and the mercury impacts, even if it was originally FGD gypsum, are largely, those happen upstream. So the old FGD gypsum drywall would be acceptable for use, as recycled content. So from a material health perspective, great. Like, we want to encourage the use of recycled gypsum, post-consumer recycled. From an embodied carbon perspective, it actually doesn't make that much of a difference because they still have to break it down, hydrate it, calcite it, and then form it into boards and dry it. So from an embodied carbon perspective, the use of recycled gypsum doesn't make a big dent in the overall embodied carbon. Still a good practice, but it doesn't impact the embodied carbon numbers as much as you would think it would.
Awesome. Okay, we've got one more question from Faith as well, which is super long. So Faith, if you're on the line, feel free to unmute yourself.
Sure. Yeah, sorry about that. So I was surprised as well when you talked about the third party verification of EPDs. And I was wondering, just in your own opinion, or maybe you had some findings on it, do you think that in the near future, those who are putting together these EPDs will start verifying, or those third parties will start verifying those CO2 emissions? Or do you think, like, based off of customer demand, or do you think that's going to be policy that really pushes that sort of there?
I'm happy to take this one, Teresa, if you want me to. So yeah, I think, and this is purely my opinion, just based on the market and understanding kind of the wave of some of the conversations we had with our interviews and our research, and having a background in sustainability consulting and carbon. I think with the recent push of a lot of like ESG, and from an investor's standpoint, I look to them as a good example of like what's happening and where can we go with that, right? So ESG from an investment standpoint is something that is pushing kind of awareness forward, but there's not a lot of stop levers involved that really like I think there's a lot of work that needs to be done, and it's policy driven. So I see the same thing kind of happening with EPDs, right? I think like in order to verify the actual data itself, it's going to require a whole host of new knowledge and verifiers out there that are capable of actually quantifying and understanding it. But in addition to that, it's going to require a more firm baseline understanding of the data itself. And so I think the industry will get there. I don't know if it'll happen in the next 5 years, mainly because I think policy drivers are going to be a huge component, but the data just, it's not, the rate at which we need it to come out would not happen as quickly as it needs to be done. And so in the interim, there's this pretty robust network of EPDs and EPD verifiers that have, been around, that are good at what they do, and they're good at verifying in the product category rules. I could see that being something that ISO, so obviously EPDs are, and like life cycle assessment in general is dictated by ISO standards. And I think the International Standards Organization will probably come up with some stuff that will help get there and to that point, but the data will always be changing. And so I kind of see this being mirrored in other aspects of everything we do, and the push toward better data with sustainability and carbon in our industry. So very long-winded way of saying policy will matter. We're not there yet, but I'm optimistic that we can get there. So I don't know if that answers your question. Yeah. And that's just my opinion. That's purely like, I should like disclose, I'm not representing Perkins and Will. I'm representing myself when I say that. Like, that's just my opinion. Yeah.
Great. Thank you.
Yeah.
And then just one last one from, I think, Anthony, who's got his hand up there.
Hey. Yeah, great presentation, everyone. Thanks. I just threw in a link of this old dashboard that I did a long time ago on the courts database, which compared HPDs with EPDs. And I'm just wondering, do you know if there's current efforts right now to kind of redo something like that, to kind of link up some of that data with EPDs, or maybe even categories of products, for example?
I'm going to find your link so I can open it. Oops, Public Hub Tableau.
I think this is that effort in some ways. The course, is currently not active. So HBN was involved in the material health side of that, the material research side of the course database. And at this point in time, there's not a effort that I'm aware of to link the EPD and HPD data. But what we're trying to do is to give that guidance, like take all that guidance and roll it up at the product type level, so that it's I guess applicable across the entire industry, and even when there's not an EPD available or an HPD available, which we hope, of course, there is for all products, that you can still get pointed in the right direction to meet your embodied carbon or material health goals, and to get pointed directionally towards product types that are going to help you get there.
Great, thank you.
Awesome.
Yeah, great question.
Well, thank you so much, Kimberly and Teresa. I think everybody here learned a lot. I did, and yeah, we're super appreciative. For anyone who joined late, this session was recorded, so we'll share that afterwards. And yeah, once again, thank you very much.
Thank you.
Thank you.